Lesson 1, operations with polynomials. Learning target, I can add, subtract, and multiply polynomials. So first, some vocab: polynomial terms containing numbers, variables, and exponents that are being added, subtracted, or multiplied. So we've interacted with these a little bit before, but now we're just adding that vocab with it. So a monomial is just one term, so we have the number, variable, exponent. Binomial has two terms, so two things being added or subtracted. Trinomial, three terms. Four-term polynomial has four terms. So the terms are the things that you're adding or subtracting. So here 3x is a term, 8 is a term, and 4x to the fifth is a term. And then we have degree of a polynomial, and that is the highest power to which the variable is raised to in a polynomial. So in this monomial right here, this would be degree 5, because 5 is the highest power. In this last example, if we look at all of our variables, a squared, b, that would be b to the first power, b to the third, the degree would be 3, because 3 is the highest exponent, that highest power. So adding and subtracting polynomials is an extension of something we have already done. It's really just combining your like terms. So now, like terms is we're gonna expand our definition of like terms. Like terms, we have said, are terms with the same variable, and then we're gonna add a piece onto that. It's terms with the same variable raised to the same power. I'm gonna say that one more time. Combining like terms, we're gonna add onto it. It's terms with the same variable raised to the same power. So if I look at my two sets, I have 2x to the third minus 5x squared plus x. I'm going to write that out, 2x to the third minus 5x squared plus x. Now I'm adding this, so I'm going to make this an addition problem, to this next polynomial. But when I write this polynomial, I'm going to rewrite it in the order in which it lines up with the other polynomial. So I started with 2x to the third. So I'm going to ask myself, does anything else have an x to the third power? And I see a positive 1x to the third. Reminder, if there's no number in front of your variable, it's a 1. So I'm going to put 1x to the third first. And then I have my x squared. So I'm going to ask myself, do I see anything with an x squared? And I see 2x to the second power. So I'm going to put underneath that plus 2x to the second power. I'm putting plus because the 2 is positive. And then I'm going to ask myself, do I see anything with just an x? I do not see anything with just an x. However, I do still have one more term, which is a minus 1. So I'm going to put this minus 1 at the end here, not underneath anything. And then we're just going to add up our like terms. So we have 2x to the third power plus 1x to the third power, which is 3x to the third power. Then we have negative 5x squared plus 2x squared, which is negative 3x squared. Positive 1x, it just comes down because we don't have anything to add to it. And then the minus 1 also just comes down because we have nothing to add to it. And this is our answer because we can't simplify it any further. We can't add anything together anymore because nothing else is a like term. Now with subtraction of polynomials, it's just one extra step. We're still going to do the same process. We're going to start with that lining up our variables. So we have 4n squared plus 5. So I'm going to leave a spot for the n's, and then I'm going to put plus 5, because we don't have anything with just an n power, but we do have that n squared and the 5. Now, because I have minus, when we minus, we're minusing every term. So I want to just change this into a plus. So to change this into a plus means I have to switch the sign on everything else. So if I change this to a plus, we're really distributing that negative. So negative times a negative would make this 2n a positive, so it'd be 2n squared. And then negative times a positive is going to be a negative, negative 2n. And then negative times a negative is a positive. So we're distributing that subtraction, which is really a negative 1 that we're distributing to each term. So then we can treat this like one big addition problem. And we just add up our like terms. So right now I'd like you to add up your like terms and check your answer in Edpuzzle. Multiplying polynomials. Now when we multiply polynomials, we're just applying the distributive property multiple times because we have multiple terms. So what I like to use is the box method, which we make a box that fits the number of terms that we have. So we have x minus 4. So that's our two terms. So I'm going to put it on the two sides. So we have x and then minus 4. And then we have our three-term polynomial, which is x squared. So x squared gets one box, minus 3x gets the second box, and plus 2 gets that last box. And then we're going to multiply top and side. So we're going to do x squared times x. So x squared is really x times x. And then if we multiply it by another x times x times x is x to the third power. Then we do negative 3x times x. We have negative 3x times x. Well, x times x is x to the second power. And we still have that negative 3 being multiplied by that. And then we have 2 times x, which is just 2x. And then we multiply the second row the same way we did the first row, except for now we're doing the top times the negative 4. So now we have x squared times negative 4, which is negative 4x squared. We have negative 3x times negative 4, so negative 3 times negative 4 is positive 12, and then we have that x joining with it, so we have 12x. And then we have positive 2 times negative 4, which is negative 8. And then we're just going to combine our like terms. Now the fun part of the box method is all of your like terms end up in the diagonals. So we have x to the third, because there's nothing else in this diagonal here that would go with x to the third, so it's x to the third. Then if we look here in this diagonal, we get our 2x squared. So we have negative 4 plus negative 3, which is negative 7, and it's x squared. Then in our next diagonal, we have 12x and 2x. We add them up. 12 plus 2 is 14, so positive 14x. And then that last one is just negative 8. There's nothing else in that diagonal, so it's just negative 8. And then that is your final answer. All right, we have 3a plus 4, so we're going to put 3a plus 4, and then a minus 2. Now remember, just a variable is really a 1, so 1a. So I'm going to have you try and multiply that and check your answer in Edpuzzle. And if you get it wrong in Edpuzzle, please check in with me during class so we can talk about it. All right, we have two more examples here. We have 2x plus 1 squared. So anything squared is just being multiplied by itself. So this really says we're doing 2x plus 1 times itself. So we're doing 2x plus 1 times 2x plus 1. So we do 2x plus 1, 2x plus 1. And then we just multiply like we normally do. 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times 1 is 2x. 1 times 1 is 1. Add up those like terms, we get 4x squared. 2x plus 2x is 4x. And then we have that positive 1. And then lastly, we have this one is like a special case, is when we have the same term except for the sign is different, plus and minus. So all the numbers are the same order. We just switched it from a plus to a minus. So watch what happens when we multiply one of these. We get 2x plus 1. And then 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 2x times positive 1 is positive 2x. Positive 1 times negative 1 is negative 1. So when we add up our like terms, we have that 4x squared. And then we get negative 2x and positive 2x. Well, those are opposites, negative 2 and positive 2, so they make 0. They go away. And then we just have that minus 1. So when you have the opposites, positive and negative, same numbers on both, it just switches from a plus to a minus, it's going to eliminate that middle term. So we end up with just a binomial as our answer. That's all your notes. You can go ahead and move into your practice.